All right, hello everyone, and welcome back to the channel. I hope all of you are doing great. So today I'm going to be participating in this Leetcode Biweekly contest 109, right? And yeah, I'm going to be recording my participation. And today my focus is, going to be on solving all the problems as fast as possible. So there is probably not going to be a lot of commentary involved here. So I won't be speaking and explaining the solutions a lot. The primary focus of mine would be, to just solve these problems as quickly as possible and get as good of a rank as possible, right? So yeah, that's what I'm going to be focusing on. So with that, let's start with this contest. Let's go for it. All right, so you're given an integer array. We consider an array good if it is a permutation of the array base. Return true if the given array is good, otherwise return false. What is base? Base n is 1 to n plus 2 occurrences of n. Looks like a weird problem. So let's just construct base. Base of I is going to be I plus 1, and we'll say that base of n minus 1 is going to be n. Right. Then we are going to sort nums. I'm, still habitual with my code forces template. So we don't have n. Okay. Right, so this should work. Yeah, so let's move on to problem B. So problem A took more time than it deserved. But let's try to, compensate at problem B. So given a zero index string S, permute S to get a new string T such that all the consonants remain in their original places. More formally, if there is an index I such that S of I is a constant, then T of I equal to S of I, the vowels must be sorted in non-decreasing order of their ASCII values. More formally, for pairs, okay, and we just need to return the resulting string. So that makes sense. Cool. So what would be a good way to implement this thing? So yeah, let's just do it. Uh, the first thing that comes to my mind, I'm just going to write that out. All right, hmm, so we form these two strings and then we'll sort the consonant string. And then what we'll do is we'll again iterate over our original string. So let's maintain two pointers, PC and PV. PC is equal to PV is equal to 0. Then we'll just iterate over the original string S. Okay. I don't know what's happened to Leetcode's indentation today. This is pretty ridiculous. Anyways, let's copy this part out. So if this is a vowel, we'll say sounds plus equal to a vow of PV plus plus sounds plus, and then otherwise we'll say sounds plus equal to cons of plus plus. We are getting we need to sort the vowels must be sorted in non-decreasing order, right? So we need to sort the vowels, not the consonants, right? Okay, makes sense. All right, let's submit this. With this system. Okay, so we also need to take into account the uppercase vowels. Okay, fair enough. Cool. Again, now let's quickly solve the third problem. So you are given a zero indexed array nums and a positive integer x. You are initially at position zero in the array, and you can visit other positions according to the following rules. If you are currently in position I, then you can move to any position j such that j is greater than I. And for each position I that you visit, you get a score of nums I. So if you move from position I to j and the parities of nums I and nums j differ, then you lose a score of x. Return the maximum total score that you can get. Okay, initially you have nums of 0 points. Okay, so this looks like a DP problem to me. So we can have DP of so we can have a 2D array DP I0, which denotes the maximum score if we were previously at an even position, and DP I1 denotes the maximum score if we were previously at an odd position. And then doing the transitions should be pretty easy, right? Yeah, cool. So I think let's just implement that. So we have this 2D DP. So initially we'll initialize everything with minus infinity, and then we'll say dp0 1, because the sorry dp0 0 is equal to a of 0, right? Cool. So we'll say dpi0 is maximum of, so dpi minus 1 0 plus a of I, or dpi minus 1 1 plus a of I minus what, x, right? And this is only done if I is even. So, and dpi0 is equal to max of dpi0 dpi minus 1 0, right? And we'll do the same thing if I is odd, right? So if I mod 2 is equal to 1, then we'll say dpi1 is equal to max of dpi minus 1 1 plus ai, or dpi minus 1 0 plus ai minus x. And then dpi1 is max of dpi1 and dpi minus 1 1. Finally, we'll return dpn minus 1 and n minus 1 modulo 2, or what? So we don't really need to end at final position. So we need to return the maximum of dpn minus 1 0 and dpn minus 1 1. So let's just define inf as 1e18. Okay. Oh, so we need the parity of not I but AI. Okay, makes sense. 13 and 20. Let's submit this. Oh, okay, that's pretty weird. Yeah. So this should be what? This should be A of 0 modulo 2, right? Again, a stupid mistake. Cool. Let's move to the final problem. We took a very, very unwanted penalty here, an unnecessary penalty. So given two positive integers n and x, return the number of ways n can be expressed as the sum of the xth power of unique positive integers. Okay, cool. So number of unique integers. Right, that makes sense. Right. Okay. Yeah. Fine. So all these integers should be unique, right? N is up till 300. All right. So again, I'm thinking of some kind of a DP solution. Right. So number of ways we can represent this number n. So I'm thinking of a DP like DPIJ, where number of ways we have use all numbers in the range from 1 to I, such that the current sum is equal to j. So then doing transitions should be pretty easy. So we are allowed O of n cube operations. So what we can do here is we can just find out the next number. We can just loop from j to n, and then just find out the next number. And this way we can just uh, update our DP values. So that looks like a pretty easy, simple DP to me. Let's just verify that I'm not missing anything because this seems a bit too easy for being the last problem, but still. Let's see. Yeah, I mean, should be that only. So initially we have used numbers till 0 and sum is equal to 0. Okay. So j is equal to 0, j is less than n, j plus plus. So now what we'll do is we'll try to find out the next number that we can put. Okay. So we'll go from I plus 1. Okay. And k is less than n, k plus plus less than equal to n. Also, let's just pre-compute powers because that would be better. So vector of VLL, sorry, vector VLL, PWR. We'll compute all the powers of the numbers from 0 to x. So there's a simple relation PWR ij is equal to PWR ij minus 1 multiplied by I modulo mod, right? Yeah. LL mod is equals to 1E9 plus 7. Yeah, that sounds good to me. Cool. So now what we can do is, uh, so the next number that we will have is, the next sum that we'll have is j plus PWR of k and x. Okay. So if this number is less than or equal to n, then we can successfully update our DP table, right? So we can say that DP of k and j plus PWR of kx is equal to itself plus dp of ij mod mod. And I think this should be enough. So we need to return dp of n. We have used all the numbers from 1 to I. So or maybe this can even be faster. We don't even need this last loop. So what we can do instead is we can say that first choice is to not add the number I plus 1. Okay. So what we'll do is dp I plus 1j is equal to dp I plus 1j plus dpij mod mod. And then we can do something like this. So the new number would be j plus PWR I plus 1x. Okay. Yeah, this seems to be more reasonable. We've used all numbers till n and we got a sum of n. So the answer will be dpnn. Let's fix all the compile errors. Okay, there are no compile errors. Right, so why is that happening? All right, this looks good to me. 1 and 2. So if we are at ij, one option would be to go to I plus 1j, and the other option would be to add this number. Right, so this sounds reasonable. Right, so it's accepted. So it took us 26 minutes. So it's actually quite an easy contest, to be honest. It is easier compared to other lead code rounds. That is something I can say for sure. And I'm pretty disappointed by my performance, to be honest. Okay, so let's see what's going on. Yeah, so as you can see, the rank is not that good as well. Although I think there is some issues with the rank, with the leaderboard right now. But anyways, was a pretty comparatively a bit easier contest as compared to other lead code contests that I've given. But yeah, it was fun participating, and thank you so much for watching. I'll see you in the next one.